The next thing I want to do is I want to point out the ratios of the trig ratios in the unit circle of a 30, 60, 90 and a 45, 45, 90. The basic angles you're going to use are going to be quadrantial angles of 0, 90, 180, 270, 360. Then we'll be using our breakdowns of 30, 60, 90, and 45, 45, 90 right triangles. So we really need to be able to work fluently with those angle relationships. So I'm going to develop this idea on this screen here. What I have is a 30-degree angle. It's 30.09, which is close to a 30-degree angle that we have. I want you to ignore this radius of 2 per second. What if this was a radius, or a radius of 1? What if it was a radius of 2? Since in our 30, 60, 90 right triangle, we have memorized these ratios and know that they are true, is that the radius has to be a length of 2. In every 30, 60, 90 right triangle, the length opposite the 30 degree is 1, and the length opposite the 60 degree is square root of 3. So if we go to a unit circle, what we're saying is we're not going to let the radius be 2 anymore. We're going to make the radius be 1. So in a unit circle, we're forcing it to not be a radius of 2, but we want it to be a radius of 1. In order to achieve that, we would have to divide this radius by 2, and 2 divided by 2 is 1. Now I have what I wanted to achieve. But if I divide one side by 2, I have to divide all the sides by 2. So then in a unit circle, we have these measurements for the opposite and adjacent sides. So I'm going to clear this up a little bit. So now I have a side which is 2 over 2, which is 1. So now if we ask about the sine of a 30-degree angle, it's just the opposite side, which is 1/2, which is the y value, over the r, which is 1, which is really convenient because every time we divide by 1, it's nothing more than half, or the y value of that ordered pair. So this ordered pair is the square root of 3 over 2, comma 1/2, according to our unit circle. So if we take the cosine of a 30-degree angle, cosine of a 30-degree angle always wants the x value, which is the square root of 3 over 2, over the length of the radius, which is over 1, or simply the square root of 3 over 2. When we get down to a unit circle, what we're going to notice is that the sine values will always mirror the y value of the ordered pair. The cosine values will always mirror the x values of the ordered pair. And then the tangents are always going to mirror the ratio of the y over x. And in this case, we've got the tangent. Let me write that over here. The tangent of a 30 is equal to, it's the y value, which is 1/2, over the x value, which is square root of 3 over 2. Writing that, I really have a half, and I'm dividing it by the square root of 3 over 2, which is a half times 2 over the square root of 3. So the 2's cancel, and I got 1 over the square root of 3, which equals the square root of 3, which was a whole lot of work to show you that the tangent of 30 is still the square root of 3. But it's still accurate. So we apply these things to the unit circle. A lot of times we're just going to go back to and drive that 1, 2 square root of 3 ratio down to a 1 square root of 3 over 2 and a 1/2. So that's what we have with a 30, 60, 90. Now if I convert this and we make it a 45, 45, 90 degree, so I'm going to buzz this up to a 45. Get fairly close. Okay, so now you can see that in a 45, 45, 90, your x value and your y value should be the same, and they are. But if we do this, what we have memorized for a 45, 45, 90 is a ratio of 1 to 1 to square root of 2. Now, under the same context here, if I want a unit circle, I want to force that radius to be equal to 1. And right now, the ones that we have memorized in our 45, 45, 90 are 1, 1 square root of 2, which makes the radius square root of 2. So to equal a 1, or to drive that radius down to a 1, we're going to take and divide by square root of 2, which means this is 1. Then we're going to take every side length. This one was a 1, so we're going to divide it by the square root of 2. If we rationalize, it's the square root of 2 over 2. And if we rationalize this one, or divide by square root of 2 and then rationalize, it's the square root of 2 over 2. So now this ordered pair that we were referencing on a unit triangle, or unit circle, with a triangle that's 45-degree angle, is the square root of 2 over 2, comma, square root of 2 over 2. So now when we ask the question, what is the sine of a 45-degree angle? It is nothing more than the y value over 1, or just square root of 2 over 2. If we do the cosine of a 45, it is nothing more than the x value over 1, which is still just square root of 2 over 2. And then finally, the tangent of a 45 is going to be the x value, which is square root of 2 over 2 divided, or the y value, square root of 2 divided by 2, divided by another square root of 2 over 2, which is the same number divided by itself, or 1. So we have these equivalencies in the unit circle for sine, cosine, and tangent of 30, 60, 90, and 45, 45, 90. And that's what I've summarized in this table in this video. So all those are the conversions. If we convert everything from your 30, 60, 90 right triangles, which you've had of a 1 square root of 2, and 1 square root of 3, 2, and 1 square root of 2, and we drive them back to a unit circle, these would be the trig values for each of those. So sometimes it's nice to have those handy, and you can access